Hi, we continue section 5.a, NPV and IRR. So now that we define the IRR, the internal rate of return, it's also called the yield rate. So remember that the net present value is defined by summation over all t of AT times v to the power t minus LT times v to the power t. And here the v is equal to 1 over 1 plus I. So particularly this NPV is a function of I. So depending on the interest preference rate, the net present value is different. So NPV is a function of I. So we write this as P of I. So if all t's are integer, this is a polynomial, and polynomial, I mean the rational function of I. And in general, that we have any shape, any power function, but at least this is a function of I, so we can write this as P of I. Then IRR is the solution of P of I is equal to 0. So that means that if we have some product or project, we have cash inflow and cash outflow. So we have some implied interest rate we can get from that product or project. So that is the internal rate of return. So that is called either yield rates or internal rate of return. Okay, so now that we have an example, so think about the example 1 in the previous video. So that was, we have the 3 cash flow, I mean the 3 cash flow. So 0, 1, 2, you receive the $1,000 at time 0, but you have to pay 500 at time 1 and have to pay 600 at time 2. So what is the internal rate of return? So at first we have to calculate NPV. So this is function of I. So PI is equal to NPV is equal to the 1,000 minus 500 times 1 over 1 plus I minus 600 times 1 over 1 plus I square. So we have to equate to 0. So what is the interest rate, implied interest rate? So you can see that you have to pay $1,100 and you receive only $1,000. So that means the probably, okay, so this deposit is in the account on average 1.5 years, and we have to pay 1.1 times more. So probably the internal rate of return is maybe the 10% divided by 1.5 years. So that is about maybe 6% or 7%. That is our guess. Okay, so to solve this, you can multiply 1 plus I. So you can multiply 1 plus I square. Then, okay, we only have the 3 cash flows at time 0, 1, 2. So this becomes polynomial with degree 2. So 1,000 plus 1 plus I square minus 500 times 1 plus I minus 600 is equal to 0. So this becomes, okay, so 1,000, and maybe we divide this by 100. So then this 1,000 times I square, 1,000 times I square becomes 10 I square, so 10 I square. The next term is 2,000 times I, and the minus 500 times I, so that means 1,500 I, so we divide by 100, then we get the 15 I. Then finally, the 1,000 minus 500 minus 600, so that is negative 100. So if we divide by 100, that becomes 1. So if we simplify this equation, we have 10i squared plus 15i plus minus 1. So you can solve this. So this means I is, you can solve the equation, and I is either negative 15 plus minus square root of 15 square minus 4 times 10 times negative 1. So this is the formula for quadratic equation. So this becomes negative 15, the plus the square root of 265. 15 square is 225, and the other part is 40. So 265 divided by the 20. So that means that this is equal to 20 and sorry, the 15, negative 15, the plus minus the 16.279 over 20. And this becomes the 0.0639 and the negative 1.5639. So actually this is the 6.39%. So in this case, this is called the positive one. Positive one is called the yield rate. So this is 6.39%. So this is the yield rate. Yeah. So yes, the positive solution is called yield rate. And what why we get the different value, negative 1.56. Yeah, negative 1.56. So this corresponds to negative 56%, right? So what that means? That means if we have $100, we have the interest of negative $165. So this is worth actually negative $56 at time 1. So that means, you know, the amount of asset and liability just changes after 1 year. Asset becomes liability. So if we think about that kind of very strange world, we may find one solution, and that is negative 156%. But it does not make sense. So we define the yield rate as the positive solution.